Okay, this is a graph of somebody going around a Ferris wheel, and by somebody I mean a dot inside of a square. Okay, this is a dot inside of a square going around a Ferris wheel. It's a very exciting looking Ferris wheel. It is a circle and a triangle. Okay, it's not a pizza. Here, let me pause this. Here's what the graph looks like. Okay, here's what the graph looks like. I know that this is very exciting, right? Goes up to the top. It's a bit, obviously that would not be a good, that wouldn't be a good ride if it was as jerky as the graph just drew, because it'd be suddenly thrown out of the seat, but it's not supposed to. It's just our internet connection, right?
No one survives.
No one survives because they get launched out of their seats at the top because the thing stopped and then you flew out. Now that I've got you sidetracked again, the model that we used here took 7 seconds to go around. This one is obviously a bigger one, and it goes a lot slower because it took how long to go around? 30 seconds up and down, and then you get 3 times around or whatever. How high is the maximum height on this? What's the highest the person ever gets? 20. What is that? If that's 32, that's 24. This is 28? 26, right? 26. What's the lowest they ever are? 2 meters. We're going to write some stuff down here for domain and range. The domain is the possible times in this situation, and the range is the possible heights for this person. Does this person ever get to 40 meters? Is it a possible height in this situation? No, it's not. It's not part of the range of this. How would you describe in words what the range is for this? For this situation? The range is the possible heights, the possible y values. 2 up to 26, right? So we're going to look together at the different things here. I'm going to just do a screenshot of this so we can write it. But I think you should possibly write this down under here, okay? If you haven't already. I'm going to do a screenshot of that graph. I'm hopefully going to put it right here, and hopefully it will. Hopefully it won't mess up this page too much. We'll make it a bit smaller. Okay, you should draw a quick little graph of, you should draw a sketch of the graph of that thing. Probably for yourself. It doesn't have to be totally fancy, and you can put just a couple numbers on there, but that's our graph, right? We're looking at different ways to write the domain and the range. In this case here, the domain is possible times, right? Okay, remember domain is, and I'm going to write it over here. Domain is possible x values, or if it's something else other than x, it's possible independent values. Okay, independent variable values, whereas range is possible y values. If you're that kind of person that needs a way of remembering that, how might you remember that? How might you remember? Because the thing that people are they're going to know that they're going to remember the words domain and range, and they're going to remember that they have something to do with y and x. What do you think they are going to forget, though, or not be sure of? Which one's which? If you want a way of remembering it, this is how some people do it. D comes before R in the alphabet, and you see where I'm going with this, right? X comes before Y in the alphabet. If that's the way you want to remember it, that's fine. Because you don't want to get things wrong because you get it backwards, right? So the domain in this situation is whatever values are possible for the independent variable. What's the independent variable again here? Is time, right? This is the independent variable, time, right? What's the dependent variable here? Height, right? So we're saying we're looking at the range up here. Let's start with the range because it's a little bit easier to see and think about. even though domain is the first word up here, we're going to write the range down first. Here's the range. Here's different ways to write the domain and range. Okay, so let's make maybe a small table here. We're going to go. How about if I say the word method? I didn't think the word method was that funny, but domain and range. Okay. Here's the first way to write it. Let's make this clear that this is a table, sort of. I would, if I were you. That's no good. I would write this down because you want to have some notes probably on different ways to write things. Yeah, in the space there it's fine. Or you can wait and do your own thing. Okay, so first way, what did you tell me when I asked you what the domain of this thing was? You said everything between 2 and 26, except I'm talking about the range, not the domain. If I say the wrong thing, remind me. The first way to express the domain and the range is with words. With words, the range, okay, the range is the blue, right? And the other one's the yellow. What values are possible in the range? What heights are possible? Heights are between 2 meters and, what was it, 26? 26 meters. So you just describe it with words, between those two values. What about the domain in words? The domain is the possible x values, or times. What times are possible in this? You start the ride, time is 0, and then you could just sit on there all day, right? What could happen? Time can just keep ticking, right? You could get dizzy. Whether the person stops or not, time just keeps going, right? This graph, if she kept going around and around there, it just keeps going. Time is, how do I write this? What do I say? Times are 0 to infinity, I guess, right? She's going to be dead before that or get really bored of the ride, but times are something bigger than 0. You could say greater than or equal to, greater than, why do I have to put or equal to? It's, yeah, at the beginning it's equal to 0. That's one way to express the domain and range. Okay? Another way is with a number line. I'm going to put the word graphically here. With words is what you call verbally. You know the word verbally. With a number line is what you call, a number line is what you call graphically. What is the word graphic? When you talk about the graphics of something, what does it mean? What does it mean? This video game has good graphics. What does that mean? Why is it called a graph? What does that word mean? No, it doesn't mean chart. The word graphic, graphics. If you say it's got good graphics, the visual aspects are good. It's called a graph because it's a visual way. Like if you say there's a graph, it's because it's representing something visually. Graphic just means visual. Okay? If you say there's graphics, violence in this, it means it's very visual violence, right? Writing something as a number line is just showing it what you call graphically. I'm going to do the domain first for this because it's an easy number line to make. Have you made number lines before? You've never made number lines? I am going to put a little mark there and say 0. I'm going to put a couple other numbers on it just to show which direction. I'm going to put the word time down here in seconds. It's a one-dimensional graph. That's what a number line is. I'm going to put, 10, 20, something like that. Basically, where are we looking on here? What times are possible? If I shade in where it is, it starts here, and which direction do the times go from that? To the right. This is what your number line looks like. It's got a solid dot at 0 to say 0 is included. And it's got an arrow to the right. Okay? If you made a number line for the other thing here, you made a number line for this. I'm actually going to make the number line this way because, why would I make the number line this way for this? Because it's height and we get mixed up otherwise. I'm going to put 0 here. And I'm actually just going to put a 2 there, you don't have to put a million numbers on there. If you have grade 8s make number lines, they go 2, 4, 6, 8, and they put every single number on there. You don't need to put every single number. It's enough just to put a few reference points on here. If you're putting this on here and the highest is 26, you could also put another one above that if you want, but is she ever right at 2 meters on the Ferris wheel? She starts there, she ends there. Where do I shade it in? What heights does she cover? From there to there, right? She covers all of those heights. Solid dot at the top, solid dot at the bottom, to say she covers everything in between those two values. Right? Let me show you something here. If we drew this graph here, I'm not drawing it very well. Let me try again. Okay. There's the graph. If you want to think about the domain and the range from a graph, if you want to think about the possible x values, imagine that you squash the graph down onto the, whoops, it doesn't squash very well. Oh, I need to miss that thing, that's why. If you squash this down onto the axis, it covers everything from 0 and above. If you squash it onto the y-axis, what part of the y-axis is covered there? You see that? That's how you, basically when you make a number line, that's what you're doing. You're just coloring in you're coloring in the parts that are covered on the axis. Okay? Here's the third way. With symbols, or what you might call algebraically. Nope, there's 5 ways. I know you are. You can fit it in. This one you can say, if you're using t here for time, you can say time is greater than or equal to, what did we say it was greater than or equal to? Time's greater than or equal to what? 0. That's how you can say it. Okay? Time is greater than or equal to 0. How about this one? This is the harder one. Can you say this with, how do you say it's between two numbers with symbols? How do you say it's between two numbers with symbols? It's actually two things. It's greater than 2, but it's also less than 26, right? It's greater than 2 and it's less than 26 at the same time. You could do this and say h is greater than or equal to 2 and h is less than or equal to 26 if you want. You could say it as two inequalities that you combine together like that. Or another way to say it is to combine those and write what's called a double inequality. Double inequality. A double inequality is when you say, I'm going to put the h in the middle and say it's less than or equal to 26 on that side, but then turning this thing around. If I turned that one around, what would it say? It wouldn't say h is greater than 2. It would say 2 is, no, 2 is not greater. I mean, if I just reversed it like this, if I completely reverse, if I said it the other way around, instead of saying h is greater than 2, could I say 2 is less than or equal to h? Those mean the same thing, right? And then it's just a question of taking this part and putting it on the other side, like this. Okay? That's how you write a double inequality. This thing right here means the same as this. It says it's greater than or equal to 2, but less than or equal to 26. You can write it either one of those ways. It's good to get used to this, because you're going to see a lot of that. That's how you can do it using symbols. Okay? One other way is called interval notation. Interval notation, if you really wanted to, interval notation is basically a similar thing here. Interval notation for this says, because mathematicians are really lazy, none of you are really lazy, right? Mathematicians are lazy. This is too much writing for them. This is way too much, right? For them. So what they said is, well, it doesn't even matter what that is. All that really matters here is the endpoints, right? So let's just write the endpoints and say it starts at 2, it ends at 26, and we need some way of saying that those are included. the 2 and the 26 are included. They're solid, filled-in circles here, right? They're closed circles. They put square brackets here to say that interval. When you see this, if somebody says on the interval 2 to 26, it means from 2 to 26, including those values. This one's harder to do with intervals because where does it start? It starts at what? Where does it start? 0. Starts at 0. Does it include 0? It does. So you put a square bracket there. What's the highest value? What does it go up to? For those of you who are listening over there. What's the highest value? Where does it go up to? Any one of you four.
26.
We're talking about this one now.
20.
Well, there's an arrow on the end of it here, see?
22.
No, even farther than that. Way bigger than 22. Somebody said it a while ago here, right? As high as you want. Up to infinity, right? So you can write that. You know the symbol for infinity? Have you seen it before? It's a sideways looking 8 type of thing. It's like an 8 that's sideways. The only thing for interval notation is, this is a tough thing here, but can you actually include infinity as a number, as a time that you could sit on the Ferris wheel? Is infinity a number you can ever get to? No, you can't. You can't actually include infinity in your interval. So you put the opposite of this. The square bracket means you're including that. This is like a number line that kept going here up to infinity. But you can't actually get to infinity, so you would have to use an open circle. Nobody's ever going to make a number line with infinity at the end. But if you could, you'd put a round bracket there to say it doesn't actually include that number, but everything up to and including that. We're going to work more with interval notation as we work on this unit.